All right, in this one I want to talk about how to make a wireframe that will eventually be used for frame generator. The reason I'm doing it as a separate thing is because there are a couple tips and tricks that will save you a lot of time later. So first thing I'm going to do is save my part, just because I've made that mistake a number of times. I have no desire to make it again. Alright, so I'm not going to be recreating an entire FSA frame in this tutorial, but I'll just show you a couple of the general things. So, wireframe is exactly what it sounds like. You're pretty much going to leave everything as a line. You don't necessarily want to make them into solids because you'll be dragging those solids along it. Pretty similar to how a sweep works, but it kind of is already automated. We'll get to that in the next one, but essentially right now you basically just want to set up all your paths that your tube profiles will be swept along. So we'll start with something of a roll hoop here. Maybe go 12 inches wide, 6 inches up, go another 6 inches up. Okay, so once I've finished in that plane, I'm going to do nothing with it. I'm not going to extrude or anything. I'm just going to leave it like it is. So for example, if I wanted some side rails here, perhaps I would do something along these lines. Another thing that will save you a lot of time and stress later is naming all your sketches. So if you double click on it, there's probably another way to do it as well, but by double clicking I'm just going to rename it roll hoop plane. It also might be worth your time if you want to make the roll hoop its own thing and then add these others as separate deals and label them as such. That could save you a lot of time as well. So now I am going to add a plane that will have our sidebars on it. So I'm going to make this visible. And I actually want to be able to make the sidebars on another plane. So I can already make them on this plane. So if I make a sketch here, say I want to go 18 inches. Say I want to go. So you can notice that sometimes you don't have the ability to go there. What you can do is go project geometry, and you just click any things that are in other sketches, and what it will do is it will project it onto the plane that you already have. So for example, I don't necessarily have to project something that's already on that plane. I can choose something here, and it will project an entire line. I don't necessarily want to do that in this case, but just in case you ever needed to do that, it will do that for you. Perhaps I'll just do that for now. Okay, so what I wanted to demonstrate is that you can actually go ahead and do the other side as well, but the way it's not as obvious how you would do that. So what you want to do is you want to take a plane and you want to go offset. Now I've used many of these options, but the one that you'll end up using the most is just offset from plane. So I will take it 12 inches. Okay, so that's in the wrong direction. So I'm going to go edit dimension. You know, the worst case scenario, you can just go negative 12 and it will go the other way. Okay, so now I want to start a 2D sketch on here. Again, I want it to be 18 inches long. And that dot's not projected on there, so I have to go do that manually. Now it is. Okay, so that's not defined because I didn't officially make that dimension 18 inches, so now it's all defined. Okay. So again, I'm going to label these the sketches. It saves you time later, so that's going to be left side bars. Sketch 2 is going to be right side bars. And I'm going to make both the planes invisible just because that's really of no use to us anymore. So you can always right click in the window or in the part tree, whichever's easier. Okay, so say we wanted something at an angle. So first, let's put in the bottom bars. Sorry to get ahead of myself here. So we're going to go 2D sketch. We're going to go ahead and, again, I need to project the geometry. Easy to forget that. Okay, and then we're going to just put in some diagonal bracing there. Okay, we're going to finish the sketch. Okay, so now we've got kind of the start of a basic frame. So again, what we're going to do is I'm going to show you how to add an angled plane, because right now we've only dealt with stuff that's in all 3 dimensions. So we're going to go angle to edge around plane. So I'm going to click this edge here, and I'm going to click the YZ plane, and it will allow me to adjust that angle to whatever I want. So again, if you have a very specific number we can lean it forward at 102.5 if we want. So we'll leave it there. We'll go ahead and do a sketch on here. And you got something to note is that you're looking as though you were looking directly down onto this plane. So let's say again we wanted to do a similar thing with the other one where we wanted to have some sort of a hoop there. Again, we have to project that geometry. So we're going to do a similar thing here, just picking some random numbers. We're going to go 12 inches across, and then back down there. Actually, let's delete that. Okay, we're going to add an arc. We're going to call that 6 inches, because then that will make it round enough like that. Okay. So now, something worth noting is that it can be slightly difficult to go back and add things. For example, say I wanted to do a bar across the top here. That can be a little difficult to go back and add. For example, if I go back into this right bars, you'll see that it actually goes back to what was available in that sketch at that time. So what I'm going to do instead is I'm going to go ahead and do what's called a 3D sketch. This is a really powerful tool, but it can get a little confusing to use. So worst case scenario, doing straight lines is pretty straightforward. Similar to a 2D sketch, you can't use geometry unless it's included in this case, not projected, because there's no plane to project it to. We're working in 3D here. So we're going to actually include all these top 4 points in this sketch. So you see all I've done is clicked include geometry, and I'm going around and clicking all 4. And now I'm going to be able to connect them in 3D space. So 1, 2. Now, there are many ways to do this. I could have somehow specified those 3 points and made a plane across them and then drawn that on the plane. I find this 3D sketch to be a little easier because it allows me to do it all in one step, especially if all the other geometry already exists. So I'm just going to rename that top. Oop, apparently it didn't want to let me. Top side bars. Okay. Make this sketch invisible just to keep it nice and clean. Okay, we're doing... Oop, went away.
Wait, Dad, she's in the family room as far as I know.
All right, so the next thing we're going to do is we're going to go ahead and add some things that will help us later. So the big one is whenever you have any curved bars, the frame analysis tool within Inventor does not like curved bars. It really prefers them to be straight, And that makes sense, and we'll talk about that a little bit more when we get there. But for now, all you have to know is that if you want to use the frame simulation tool in Inventor, it makes your life a lot easier to go ahead and use straight pieces. So what I'm going to do is I'm actually going to go back into that original sketch, and I'm just going to right-click this, and I'm going to click construction, just so we can still use it, but it doesn't necessarily appear as a piece. So I'm just going to split this into 3 segments, and basically I don't want to split it into 2 segments because that will give be a little bit oversimplifying. But if I do too many more than that, it's going to take me a really long time, and you start getting diminishing returns in terms of accuracy. So kind of use your best judgment here. I wouldn't do too much more than this much bend. So we're going to dimension these so that they're equal. I think I'm going to try to dimension an angle if I can. Yeah, I'll call that 60 degrees. Same thing here. Okay, so it doesn't like that. Okay, so sometimes it gets confusing when you're not sure exactly what's going on. I'm not really sure what's still free and what needs to be constrained. You can tell it's green if it's unconstrained. Blue means constrained. And you really want to have everything constrained, or else you can have something blow up later. So what I'll encourage you to do is right-click on the thing that you're not sure about. Go to Show Degrees of Freedom, or Display Degrees of Freedom, rather. And it should, if it's working properly, display it. Now you can also just go through and drag it, and it'll show you what's going on. In this case, I'm not really sure why it's still unconstrained. Oh, there we go. The length wasn't constrained. Okay, so we're going to go ahead and finish the sketch. We'll give this one the same treatment real quick. Oh, we don't have this one labeled yet, but we'll go back and do that in a second. For the moment, we're going to give this one the same treatment. Okay, so we're going to dimension at the same angle, just for consistency. Okay. Okay. So now we have a frame that we can simulate. Obviously, you could go ahead and do this in 4, or 5, or 6 to have even more accurate results. But in Formula SE, this particular application, the tube size for a lot of the bent tubes that we use, for example, the main roll hoop is already specified in the rules, so that's actually not an area of design space that we're too interested in. However, it does affect the areas around it, so it is worth... If I was going to actually do this for the chassis and I was doing that much bend, I would probably consider doing it in 4 or 5 segments. Okay. For the next portion, I'm going to go ahead and jump over to a different model, just to show you some more tools that you can use. All right, so now we're going to talk about something that you might find useful a little later in your build process. Okay, so what we have here is the PR4 Parks Racing chassis that's being constructed as of 2020. This is the chassis that I've helped design that I'll talk about a little bit later, but for now we're just going to focus on some of the wireframe tools. And this one I wanted to talk about is, again, associated with the 3D sketch area. So what essentially happened here was the front of the frame was the geometry was set in stone, and we wanted to figure out what the rear geometry was going to be. So usually the way we'd done that traditionally was by placing the engine in the jig, and then by assembling the diff box around it, and then kind of putting our frame tubes to it. I wanted to do that in CAD ahead of time so that we could kind of get an idea of what strength properties that approach would give us. So the way you can do that is get a solid body model of the engine that you have. This one I found on GrabCAD, and this is last year's diff box assembly that I had from previous years of CAD, and I imported them into an assembly with the existing portion of the frame. Now if I hide the wireframe, actually let's make that not transparent. If I hide the wireframe here, where's the wireframe? Okay, if I hide the wireframe here, all that these tubes even weren't there at the time. All that was here was the roll hoop and forward. So what I did is I assembled the engine into place, and then I engine and diff box into place, and then what I did is I actually remake this enabled. I will make this transparent again. Make the frame transparent and enable this. Turn the visibility on. Okay, so now we can see it. And what I did is I double clicked into that. So now I'm actually editing the wireframe within this assembly. And what that allows me to do is to create a 3D sketch, which you do here, and then you can click include geometry, and now I can include any of these faces, points, lines, whatever you want, from anything else that's within that assembly into the wireframe sketch. And the reason that's useful is I was able to take the center points of the engine mounts and pull them into the wireframe sketch. And what that left me with was a point cloud of all of the mounting points that I wanted the frame to hit. And then what that allowed me to do was draw lines from existing points in the frame that we knew we wanted the engine to attach to and draw them back. And that was kind of how I did this approach. Okay, so now we got to a point where one of our chief engineers told me, hey, the engine actually has to move. It's not going to fit where we initially thought it was. Okay, so really my first reaction was, oh goodness, now I'm going to have to go back and redo everything. But something I wanted to note here is that you can do something called a 3D transform. So what I'm going to do actually is open the wireframe all on its own, as opposed to editing it with the assembly. And what you can do, you can actually see the point cloud here somewhere. Okay, so this is called engine diff box projected geometry. And initially what it was, so if we click here, edit 3D sketch, you can see what existed at the time. I literally pulled these points straight off the engine and diff box assemblies. Now say these things have to move. Okay, so you can do something called a 3D transform. So I will highlight everything, and now you can move them around however you want. So say we want it to go ridiculously high. So we can click Finish Sketch, and if there are no errors, everything else further down the part tree here should propagate to the new points. Let it load for a second. I don't know if it worked or not, but that is what I've done before. If we go here, 3D transform, go up, click check, and then finish sketch. So you can see now that it's actually moved everything around. So that is one advantage of using the 3D sketch tool. I'm going to undo this because I don't want that. Okay. So for example, say you had some independent thing that mounted on your frame, or a set of points that you weren't sure about that had to remain in the same location relative to each other, then this might be a good tool for that.